So here's your first exercise. Right now, you're going to have to take a leap of faith that I did the rotation correctly. And again, I still haven't gone over the details of the rotations yet. That's me. What I want you to do is, there's actually a lot of things in here that make common sense. At least I hope so. So in the exercises, you're given two types of rotations, of a zigzag and a zig-zig, and why they're called that is being highlighted right now. Remember that your targets are the double circles here, and now those were either in the tree or just placed in the tree, and now we want to move them up to the very top node that you see in both of these. So what I want you to do for right now, this overall concept and exercise is just trying to make sure that you understand that the rotations don't hurt the tree. They still end up being binary search trees when everything is said and done correctly. So all I want you to do for both sets of these, and we'll go over them here in a minute, is the 4 questions that I have right here for you. So pause it, take your time, count them, all that good stuff, and we'll come back and go over a solution here in a moment. All right, so let's do zigzag first, which is the topmost one. Question number 1 is it still a binary search tree? And again, to tell if it's a binary search tree, we just check to see if the order is right, if it kind of wave here from lower to higher. And the answer is yes. If we did 32, we know it's less than 35, it's greater than 25, there's 32. You know, that's test, we're good to go. The next is how many links actually changed? Well, that one's being highlighted right now, but notice you're probably going to say, well, that's a heck of a lot of links. And it is for now, and that's only because this is a very small tree. When we get larger and larger trees, there are not going to be as many links that are going to be changing hands because there's going to be more and more branches that we frankly don't go down, don't need to go down, don't need to change. So it does seem like a lot at first. And then the last one is, in the zig-zig, who lost and who gained a child and why? So you would do the same 3-4 steps that we did. Is this a binary search tree? Yes. How many links changed? It was actually, I think it was a pretty significant number on this one too. And then why they have to change, because they have to be in binary search tree order. Now, who lost some kids? Well, number 1 is that notice that 10 was originally linked to 5 and 11. Well, something happened to 11. But here's the deal, is that when we moved 10 up, we had to give 11 off to somebody. And who was its nearest neighbor? And that would be, frankly, either 17 or 15. Okay, but all we're going to do is replace it and say, look, 10's got to move up. We need that spot to be taken. So we're going to do a shift, and I'll go over child handoffs even more. And notice 11 gets handed off to 15. Now, doesn't that make sense on where 11 needs to go anyway? Was there anywhere else that 11 could have gone? No. 15 was going to end up losing somebody, okay? It was going to end up losing 10 somehow. It was going to end up losing some kid. So it picked up another kid, and that ended up being 11. But again, 11, this should make sense. 11 had nowhere else to go other than beside 15. And guess what? 15 had a hole and had lost a kid. Now it gained another one back. So that's how this is going to go with rotations, with child handoffs. There's a lot of terms that we've gone over so far that I just wanted you to take a look at. That's all I'm after. If you don't understand it completely, you're fine so far because I'm going to go into detail of each one of those here in our lecture.